Learners, a very good morning to all. I am Dr. Shagufta Khan from the School of Electrical, Electronics and Communication Engineering. So in this lecture, we will see the future HVDC projects in India. So this topic comes under the subject facts in HVDC. So the first multi-terminal HVDC projects, that is 800 kV multi-terminal HVDC system. So northeastern region has a large quantum hydroelectric power potential, as we know, at the north side. Then under hydro development program of Government of India, this power has to be evacuated and it is dispatched to the load centers of northern and western region. Now the multi-terminal HVDC link, where we are having more than two terminals of the HVDC system. So that is called the multi-terminal system, where we have rectifier and inverter station more than two. So here the power grid is installing, that is plus minus 800 kV. 6000 megawatt HVDC multi-terminal system of approximately length, that is 1728 km from northeastern region to Agra. So this is connecting from northeastern region to Agra. And so here the one rectifier station is in Biswanath Chariali, that is in northeastern region. Second one is the Alipurdwar, it is in eastern region, and the inverter station at Agra in northern region. So these three stations are interconnected, and this is the first time this is the first project in India which is multi-terminal and working on 800 kV HVDC system. Now, what are the features of this project? The converter station at Biswanath Chariali and Alipurdwar each handles a power of 3000 megawatt, and the converter station at Agra handles 6000 megawatt power. So here two rectifier station, that is 3000 megawatt, and this inverter station is at Agra, so it is having, there is 6000 megawatt. Now this transmission system originates from Assam and passes through West Bengal, Bihar, and terminates in Uttar Pradesh. It is connecting different states. Then it's a first multi-terminal HVDC projects in India. It's a big project which is handling by BHEL. Next, what is the now you can see the stations, that is Biswanath Chariali to Alipurdwar, two stations. Biswanath Chariali, this station is the Biswanath Chariali, then Alipurdwar, and this is the Agra station, you can see. So this is 400 kV, and then 400 kV, and plus minus 800 kV we have bipole HVDC system, and total 6000 megawatt is transferring through this HVDC link. Now what are the features? It's first plus minus 800 kV multi-terminal HVDC projects in the world. So it is this high voltage level plus minus 800 kV. In case of the multi-terminal DC system HVDC, it's the first project in the world. Then first 12 plus 800 kV terminal of the world. Then first multi-terminal with continuous 33% overload features is in this project. This overloading feature is also available, that is 33% overloading we can do. Then after considering the continuous 33% overload feature, this will be highest capacity HVDC projects in the world. So this is the first project in the world which is multi-terminal and working on a plus minus 800 kV, and the overload capacity is also 33%. So this is the first project in the world. Each pole of the multi-terminal shall be designed for 2000 megawatt, which is the highest capacity poles in the world. Each electrode shall be designed for 5000 ampere. So shall be the first of its kind in the world. This project is very important in India. Now, what are the advantages of multi-terminal HVDC? Create power pooling points to collect power from several generating stations and to transport it to plus minus 800 kV DC bipolar lines. So we are having the options to interconnect multiple systems through HVDC line. So power highway to major load center located far away, we can transmit the power. Then efficient utilization of plus minus 800 kV line by connecting parallel HVDC converter physically at different locations. Then 33% continuous overload capability gives higher availability for nominal power transmission for Northeast Agra multi-terminal stations. Now we also actually that this is also the proposed project in which is connecting India to Bangladesh, and that is 500 megawatt project. Here interconnection between India and Bangladesh grids is representing here. So by using the HVDC link, we can transfer the power from India to any other neighboring countries or far away, because this is the feature in HVDC system in which we can transmit the high voltage power. We can transmit high voltages, and the losses are also very less in case of HVDC system. And we can have the through C cable we can transmit the power. So these are the, and return conductor is also available in the HVDC system, that is through ground. So these are the features of the HVDC system which we can use. So day by day the HVDC projects are increasing. Next, the first interconnection between eastern region India and western Bangladesh. So it's the first interconnection. Okay, then power grid consultancy assignment is there. Scope pre-award engineering, then financial of bidding document, assistant and tender evaluation, post-award engineering, then construction supervision is there. Now India-Sri Lanka interconnection. So the India and Sri Lanka interconnection project through HPDC link is also going on. That is connecting Madurai, Rameshwaram, then Telemanar point of the Sri Lanka. So this is the route which is showing how the power will transmit from India to Sri Lanka. So this interconnection is showing Madurai, then Rameshwaram, then Telemanar at Sri Lanka point. Now what are the features? Indo-Sri Lanka HVDC interconnection project through HVDC link plus minus 400 kV 4 into 250 megawatt HVDC bipole transmission link is there. Then from Madurai, India to Sri Anuradhapuram, Sri Lanka, project having overhead line approximately 334 kilometer is the overhead line, and submarine cable is also included, that is approximately 90 kilometers. So see, this overhead line is coming, then power is transferring through the sea cable. So the submarine cables are also there, and Sri Lanka again it's an overhead line. So this is the route of the submarine cable for the Indo-Sri Lanka HVDC project. Then Champa Kurukshetra plus minus 800 kV 3000 megawatt HVDC link. Here also have BP generation project coming up in Chhattisgarh for transfer of power to different target region, that is based on the northern region. Above generation project are mainly coming up in Raigarh near Kotra, Champa, and Raigarh near Tamnar complex. Based on the transmission system requirement for transfer of power to northern region from the generation project, following western region northern region interconnection for IPP projects in Chhattisgarh is proposed. So establishment of 3000 megawatt 800 kV HVDC bipole terminal station each at Champa pooling station western and the Kurukshetra northern region respectively. So these are the projects. The Kurukshetra, that is also the proposed project. Then Champa Kurukshetra plus minus 800 kV 3000 megawatt Champa Kurukshetra, then it is upgraded to 6000 megawatt by parallel converters. Now, advantages of having third conductor for return path. What are the advantages? It eliminates the element of uncertainty about the proper functionality of the earth electrode station. Then it shall avoid acquisition of separate land for each other electrode stations. Then construction of electrode station which involve requirement of large amount of steel rods and coke. The construction of new transmission lines between eastern electrode and the southern station and respective HVDC terminal station shall be avoided. The future challenges, what are the future challenges in case of HVDC transmission? That is growth drivers, transmission growth driven by strong GDP growth, requiring massive expansion of power sector, then uneven distribution of energy resources, and change in generation profile. So these are the challenges which we have to face in the transmission sector. Then future power scenario, if you see the peak demand is going to be increased, so that is in gigawatt. In 2012 it was 152 gigawatt, in 2017 it was 218 gigawatt, and in 2027 approximately more than 500 gigawatt. That is the uh, demand of the power in gigawatt, and installed capacity we have up to 2027 approximately 575 gigawatt. So you can see how the power demand is increasing day by increasing yearly. So we have to match that demand, so we have to choose the appropriate transmission for transmitting the bulk power to the transmission lines. A need of new initiative in transmission line. What is the need? Like we are transferring the power from the AC transmission, then DC transmission. So the need for long distance transmission system, because we and there is a need to interconnect two countries or multiple countries in multi-terminal system. We can have the minimum use of land at right of way. We also think about that. Like right of way required in in the transmission, it should also be less than optimal cost per megawatt transmission. Then optimal transmission losses, we have to optimize the losses, we have to optimize the cost, we have to use the minimum right of way for the transmission system. So these are the initiatives which we can take in the transmission system. Next, these are the references which you can follow for this topic. Thank you so much.